Okay, esterification reactions. So the other day you should have looked at drawing and naming esters. And you would have seen that when we talked about drawing and naming the esters, we talked about how esters were made from a carboxylic acid combining with an alcohol. We also kind of talked about how you had to be able to figure out which part came from the carboxylic acid and which part came from the alcohol so that you could figure out which part went into the first part of the name and which part went into the second part of the name. So hopefully that should make esterification reactions a little bit simpler because you already kind of have an idea of what your two reactants are going to be. So in general, when we look at an esterification reaction, we are going to have the alcohol combining with that carboxylic acid. Okay, when they combine together, they are going to produce our ester and they are going to produce water. So how they are going to go about producing water, if you think about it, we're going to have to take an H and we're going to have to combine it with an OH. So it really doesn't matter which one you take the OH from. Let's just take it off of here. And so if I take the OH off of my alcohol and I take the H off of my carboxylic acid, those two are going to go together and that's going to generate my water molecule that I have over here. But in doing that, this oxygen now becomes short of bond, right? It had two, by getting rid of that H, it's down to just one. The same thing happens over here, right? So here's that R prime. We talked about R prime before as just being some carbon or carbon chain. So that carbon used to have an OH attached to it, now it doesn't. So that means that this is now short of bond. So what we find happening is because this oxygen is missing a bond and this carbon is missing a bond, they are going to bond together, right? So when you look over here, right, we've taken this molecule, we've kind of shifted it this way by 90 degrees to get it in this orientation, right? So here's that O, and now that O is attached to that R prime. Okay, so there's our ester because we have that C double bond O to that carbon chain over here. Okay, so you will sometimes see that esterification reactions get called condensation reactions. Okay, why they get called condensation reactions is they made water. Okay, any type of reaction that produces water as a product is generally known as an esterification reaction. Okay. So our synthesized esters can be used to give those artificial flavors to juices and fruits, right? So if you think about like when you're a kid and you had that banana medicine, that banana smell and taste is actually an ester, right? Or when you have gum, so particular wintergreen, if you have that kind of gum, wintergreen is actually an ester that we can synthesize in the lab. If we were actually at school, we would potentially be doing an esters lab and actually be making that. And you'd be able to see that we can make all kinds of different flavored scents. And they do also generally have a taste to them as well. But obviously if we were actually in the lab, we wouldn't be tasting them because we don't really want to be eating things in the lab. But when they do this for like food purposes, obviously they make sure that everything is like cleaned properly and for food, okay? But yeah, esters can give things that nice fruity smell or that nice fruity taste, okay? All right, so let's look at some examples of what this is going to look like. So here's our first example. We have acetic acid plus propan-2-ol. So like we talked about the other day, you kind of want to have that little mental checklist of what type of reaction something could be. So far we talked about combustion. We said you would recognize combustion because it was plus oxygen. We don't have plus oxygen, so it's definitely not going to be combustion. We could do addition, but we needed an alkene or an alkyne. When we look at these two molecules, neither of them are alkenes or alkynes, so addition is out. We then talked about the possibility of doing elimination. So although we have an alcohol, we do not have a strong acid. So this is not going to be elimination. Also not going to be substitution because we are not meeting the requirements to do substitution, right? With an alcohol, we can only turn it into an alkyl halide, which we don't actually have. All right, sorry, just had a pretty epic sneeze if you saw my face losing it for a second there, but I think I managed to pause it before. Okay, so acetic acid and propan-2-ol, we were working through our options. We had said it wasn't elimination. Also not substitution, because although we have an alcohol, we don't have that HX molecule. So then we get to esterification. We need an alcohol, which we have, right? We have this propan-2-ol, so there's our alcohol, and we need a carboxylic acid, and we have that when we have that acid. Okay, for the most part, I don't want to say look for acid, but if you have like an oic acid, that will work. You'll notice here we use the common name for acetic acid, but we also could have used the IUPAC name, which would be that ethanoic acid, right? Which would look a little bit more like what you're looking for. It has that oic acid at the end to kind of tell you that it's a carboxylic acid. Okay, so when we go about drawing these, right, we are going to have our CH3 going over to that C, which is then going to have that, oh, sorry, I'm still in purple mode. I'm going to have that double bonded O, and then over here is going to have that OH, okay? Then we have that propan-2-ol, right? So we know from that that we are going to have 3 carbons. We know that off of the middle one, we need to have an OH, so that means there are H's in all of the other spots. So you can go ahead, fill that in. Okay, so now we have our propan-2-ol. We filled in all those pieces. So once I look at this and recognize that it is going to be esterification, I need to know that that means this OH and this H are going to come together, right? And they are going to come together to give me that water molecule. Okay, then what we are going to have is we're going to have this carboxylic acid joining up with this alcohol. So it tends to be easier when you are drawing them yourself to start with the carboxylic acid part of it. So start with that CH3, then that C, then we can go into this double bonded O up here, right, because we didn't do anything to that. You know, we can come down to this oxygen over here. Okay, but now this O is missing a bond. So how it's going to fix that is it's going to attach over to this carbon, okay? And it's choosing that carbon because that's where we lost that OH. So for me to be able to attach to the middle carbon, I'm basically going to have to take that whole alcohol molecule and kind of rotate it this way so that I can actually attach it in, right? Because this oxygen needs to go to that middle carbon, which is still going to have those other 2 carbons attached to it, right? So if you look at this, I basically taken this molecule and I flipped it on its side so that I can actually attach that O right here into that carbon, okay? And then that leaves me with all of those other H's because we didn't touch them. Okay, naming wise, we wouldn't really ask you to name this one, and the reason we wouldn't ask you to name this is technically a branching ester, and we don't tend to get into that. Okay, in Chem 30, when we ask you to name our esters, we usually stick with just a straight chain in both of those spots. We don't worry about it, okay? So that is basically what that is going to look like.